How are you, my friends? In this video, I'm presenting 8 old exams questions related to graphs of tangent, secant, cotangent, and cosecant functions from lectures 17 and 18. Question number 1, we have a tangent function, f of x 3 tan 1 over 3, bracket 9x plus 3 pi over 2. Find the interval or intervals where the graph is above the x-axis if x between minus pi over 3 to pi over 3. So the idea here is to graph this function and look at this interval, given interval, and see where the graph is above the x. Now, first we multiply 1 over 3 times this bracket here to find the correct argument. So 1 over 3 times 9 will be 3x plus pi over 2. So this is the correct argument. To graph tan, first we find the period, the formula pi over k. K is 3, so pi over 3 is the period. Now the first period starts where the argument is equal minus pi over 2, and then it will end where the argument is pi over 2. So take the argument from here, 3x plus pi over 2 equals minus pi over 2. So S, the starting point will be minus pi over 3. So this is the starting point. This is S here. Now take the argument equals pi over 2. You cancel this, E will be 0. So the end will be 0. The end of the first period. From minus pi over 3 to 0, one period. From 0 to pi over 3, another period. From pi over 3, you add pi over 3, you get another period. Because every period is pi over 3. So this is 3 periods for the graph. Now let's see, the question says we need x-intercept, right? Yes, we know we need this x-intercept. So to find x-intercept for tan, put the argument equals n pi, where n is integer. We take the correct argument, 3x plus pi over 2 is equal n pi. Take pi over 2 on the other side, divide by 3. So x will be minus pi over 6 plus n pi over 3. If you put n equals 0 here, you can put any integer there. Put 0, you get minus pi over 6. If you put 1 in the n here, n should be an integer. So you get pi over 6. If you replace n by 2, n by 3, n by 4, n by minus 1, minus 2, minus 3, every time you will get an x-intercept. So let's see now, this is our interval, between minus pi over 3 to pi over 3. So this is the graph that we need above the x. See, I made it green here. See, the whole graph is blue. So I made it green to show you this is above the x. From where to where? From minus pi over 6 open to 0, union pi over 6 to pi over 3. That's the intervals where the graph is above the x. Now here we have, the graph is given of a tangent between minus 1 and 3. And then we need to find the equation of this tangent function where this is one period. So we can look at the graph and find the period from there between minus 1 and 3. So we have minus 1 and 3. So I can use the absolute value of m minus n, which is 3 minus minus 1, so the period is 4. I know the general tangent function, A tan k in the bracket x minus b. B is the shifting, see x minus b. B is the shifting, right or left. Now let's see the period, pi over k for tangent, but we have found that the period is 4, so I put 4 equals pi over k, so k will be pi over 4, that's k. Let's see the phase shift. This is the given. So we can imagine the graph before shifting like that. So it is shifted 1 unit to the right. See, this is minus 2, it comes in the minus 1. That's in the given. And this is a 0, goes to the 1 here. So B is plus 1 because shifted to the right. So now we have the function A tan. The k we have found, pi over 4, x minus, and b is plus 1. So the b only plus 1. Let's take one point here. One nice point. I can see 2 minus 2. See, from the given graph, 2 minus 2. See this point here? I can use this point to find the a. So the x will be the 2 in the x here, and the minus 2 in the y here, f of x. So just replace this point, minus 2 in the y, 2 in the x. You get minus 2 equals a tan pi over 4. Tan pi over 4 is 1, so a will be minus 2. So now the function is, this is the answer here, minus 2 tan pi over 4 x minus 1. Now you can write it in this form. This is another form, the same function, but see, this is more nice maybe. Minus 2 tan, just multiply pi over 4x minus pi over 4. This is the same function as this. Question number 3, we have a secant, 5 secant 3x minus pi over 6. We need the sum of the vertical asymptotes in this interval, minus pi over 2 closed to 7 pi over 6. So first, as usual, as you know, now you have to find the correct argument. If you multiply here the 3 inside, 3x minus pi over 2. That's the correct argument. Now we need the equation of the vertical asymptotes. We know the secant function is the reciprocal of the cosine. What will make the cosine 0? So we let argument equals pi over 2 plus n pi, where n is integer. So I take the argument here, 3x minus pi over 2 is equal to formula pi over 2 plus n pi. Take this on the other side, becomes pi, and then divide by 3. So x will be pi over 3 plus n pi over 3. Now, this is the same here. You see, this one is the same. This is the equation of the vertical asymptotes. Every time you replace n by any integer, you will get one vertical asymptotes. Now, we have to know how many vertical asymptotes in this interval, in the given interval, minus pi over 2 to 7 pi over 6. See, this is the equation I have found before. So I can put this, we create an inequality here. So we put the equation of the vertical asymptotes between minus pi over 2 to 7 pi over 6. Remember, this is both closed. Sometimes both are open, sometimes half open, half closed. It depends on the given. So we subtract now pi over 3 from every side, and then we multiply by 3 over pi. So what do we get here? We get minus 5 over 2 less than or equal to n less than or equal to 5 over 2. So we need all the n's between minus 2.5 to 2.5 closed. But remember, n should be integer. Let's find all these n's. So it will be minus 2, minus 1, 0, 1, and 2. So there are 5 vertical. If we need the number of the vertical, there are 5 vertical asymptotes between minus pi over 2 to 7 pi over 6. Now let's use this equation here, the equation of the vertical asymptotes, and put the values of the n's. N minus 2, you get this x, n minus 1, n0, n1, n2 from here, from this one. Then you find 5 verticals. The vertical asymptotes are minus pi over 3, 0, pi over 3, 2 pi over 3, and pi. So when you add all these 5 numbers, you will get, see, this is 0, this is 0 also, this is LCD 3, so 5 pi over 3 is the answer. Now, given this cotangent in the absolute value, the whole function in the absolute value, where the graph of this function is increasing over the interval open minus pi over 2 to pi over 2. You have to know the graph of cotan, which is so easy. Now, the graph of cotan is the dashed one. See, the graph of cotan from 0 to pi is the basic period, and then pi to 2 pi, from minus pi to 0, minus 2 pi to pi. So I have drawn here 4 periods. See, the dashed one is the cotan of x. Now, if I put absolute value on the whole function, that means all the negative part. The negative part means where y is negative below the x. See, every part below the x, I have to make it above the x because the absolute value of a negative number is a positive number. So now the red one is the graph of the absolute value. So let's see, this is the red graph here is the absolute value. So let's see our interval from minus pi over 2 to pi over 2 here. See from this to this, where the graph is increasing from minus pi over 2 to 0. This is the increasing like this. See, it's going up. Graph is rising. This is a decreasing. So only from minus pi over 2 to 0. Given the function 3 over 2 secant 2 times 2x minus pi over 2 outside minus 2 over 3. We need to find the domain and the range of this secant function. As usual, we have to find the correct argument. Why I say correct argument? Usually we call it an argument. The correct argument means if you have any mistake in the argument, all the answers will be wrong. So make sure you get the correct argument. 2 times 2x, 4x minus pi. That's the correct argument. Now we need the domain of the secant. Remember secant, 1 over cosine of x. So we let the argument equals pi over 2 plus n pi. I take the argument here, the correct argument, 4x minus pi equals pi over 2 plus n pi. Take pi on the other side, you add here 3 pi over 2, all the details are there, divide by 4, so you get x equals 3 pi over 8 plus n pi over 4, where n is integer. So this is the equation of the vertical asymptotes. So what is the domain of this big, nice function? It will be all real numbers except the vertical asymptotes, 3 pi over 8 plus n pi over 4, where n is integer. That's the domain now. Now let's see the range. Range, we have to use the formula. There is a formula for the range for the secant and cosecant. Minus infinity to d minus absolute value of a union d plus absolute value of a until infinity. Now let's figure out the numbers here. The a, which is the coefficient of the secant, 3 over 2. See, I wrote here a 3 over 2. And the d is outside. This is not in the argument. Minus 2 over 3. This is d. You can write it at the beginning also. See the argument only whatever in the bracket and inside the secant. Okay, now, so d minus 2 over 3, see d without absolute value. A, we have to put absolute value, but in this case, a is positive. Sometimes a is negative. You put it inside the absolute value. And then you add the fractions here, minus 2 over 3 to minus 3 over 2. The LCD is 6. So that's minus 4, minus 9. This is the range union 5 over 6 to infinity. Question number 6 is really nice question because you have to do some work here. You can try it, please. If this is one of the nice questions you can try before you see the answer if you like. 3 cosecant pi over 5 minus x over 2. Outside we have minus half. Now, if the period of this function is capital D and the phase shift is capital T, let's find the value of capital D plus capital T. You can try it if you like, and we have to rearrange the argument here. See, this is pi over 5 minus x over 2, something like that. So let's rearrange the function. 3 cosecant pi over 5. This is the given exactly, minus x over 2. So I put minus x over 2 at the beginning, plus pi over 5. See, I put the half, minus half at the beginning. No problem, it's the same. You can put minus half at the beginning. Now, so minus half is there, plus 3 cosecant. I take a minus here, common factor. Inside the bracket, minus x over 2 minus pi over 5. I know the cosecant function is odd. So cosecant of minus theta is minus cosecant of theta. Remember that. Cosecant of minus theta is equal minus cosecant of theta. So the function now becomes minus half. See, plus 3 becomes here minus 3 cosecant x over 2 minus pi over 5. Now the correct argument here is x over 2 minus pi over 5, which is the same as in the argument pi over 5 minus x over 2. So I can take half here outside. Now becomes half x minus 2 pi over 5. If you take half common factor, then easily you can see the shifting here. See, the shifting capital T will be the positive, only x minus small b, 2 pi over 5. If you don't take half common factor, you can say phase shift, put the argument equals 0. You can take this argument or you can take this argument. It will give you the same answer here, you see? X equals 2 pi over 5. So whatever you do, take half out, don't take half out, this argument or this argument, it will be t 2 pi over 5. Now the period is 2 pi over k. K will be the half here. So 2 pi over half will be 4 pi. So you add now 4 pi plus 2 pi over 5 will be 22 pi over 5. Question number 7, we have a graph of cosecant function. This is for one period. Let's find the equation. So from this minus pi over 2 to 3 pi over 2, that will be one period. So I can say from absolute value of m minus n, 3 pi over 2 minus pi over 2 will be 2 pi. So from here, from minus pi over 2 to 3 pi over 2 will be 2 pi. Now this is the given graph. See, this is part of the cosecant function. If you continue the graph, see, I said here more clear graph. You can continue here. You can see the graph. You can continue the graph from minus infinity to plus infinity. And now you can imagine the graph before shifting. See, this is before shifting. So this one, if you go on the left, see this one, this is before shifting. See, this is the graph here from pi to 2 pi. If you take it to the left, it becomes this one or this one, which is the same as the given. So on the phase shift now, b is minus pi. And also we found p, the period is 2 pi. And by the formula, the period 2 pi over k. So k will be 1. Now let's take a point on the graph pi over 2, 1, this point here in the given graph. So I can put x pi over 2 and then y is 1. 1 equals a cosecant pi over 2 plus pi. So a will be minus 1. So the function we need is minus cosecant x plus pi. This is the function of this one here. Now, this is really nice. We have 4 things to do. Graph the function. See, I did not put here a, b, c, d. Graph the function. This is like a bonus. The function f of x, cotan pi bracket 1 over 4x plus half. This is the whole function cotan. Now, over the interval minus 4 to 4, let's find the zeros of the given function between minus 4 to 4. Finding the zeros, you know the zeros, the x-intercept. Find the vertical asymptotes between minus 4 to 4, and then answer where the graph is below the x between minus 4 to 4. So all these 3 parts between minus 4 to 4. Let's start with the graphing. For sure, we have to rearrange the function, multiply the pi inside. You will get cotan pi over 4x plus pi over 2. So the correct argument with a nice color here is pi over 4x plus pi over 2. So the period is pi over k. See, what is k now? Pi over 4. So pi divided by pi over 4 will be 4. See, this is the 4 now. See the period here, one period from minus 2 to 2. Why from minus 2 to 2? Let's see. For the cotan, we take the argument equal to 0, then we find where the graph starts. So s will be minus 2. Just take the argument, pi over 4x plus pi over 2 equal to 0. Take the same argument, pi over 4x plus pi over 2 equals to pi. Then e will be 2. So the graph will start from minus 2, it will go to 2. Because there is a shifting here on the left. So this is one period from minus 2 to 2. Now, To find the zeros, this is the same way as finding x-intercept. To find x-intercept for the cotan, you put the argument pi over 2 plus n pi is equal to argument, yes, where n is integer. So I say pi over 4 x plus pi over 2 is equal to pi over 2. That's the formula for the cotan in the x-intercept. So this will cancel. See, this is a 0 here. Then you multiply, so 4 over pi over 4 x is equal n pi, multiply by 4 over pi, x will be 4n, the equation of x-intercept. Now, what do we need? We need the x-intercept between minus 4 to 4. So I put all this equation here between minus 4 to 4 closed. That's the given interval. And let's solve this compound inequality using algebra course, lecture number 25. If you want to review it. Now divide by 4, we get minus 1 less than or equal to n less than or equal to 1. So what are the numbers here? Minus 1, 0, and 1. These are the values of the n integers between 1 closed, between minus 1 closed and 1 closed. So there are 3 x-intercepts. Let's find them. Put n equals minus 1, you get x equals minus 4 in the equation. This equation here, you see. Put n equals 1 and put n equals 0. So now we say the zeros are x equals minus 4, x equals 0, x equals 4, between minus 4 and 4. Now let's continue here, finding the vertical asymptotes of this cotangent function. You know, cotan of x will be cosine of x divided by sine of x. So when you find the vertical asymptotes, you have to put argument equals n pi, where n is integer. So we have the correct argument, pi over 4x plus pi over 2 is equal n pi. Now simplify the equation, you will get x equals 4n minus 2. This is the equation of the vertical asymptotes where n is integer. Please try to do it, so easy. Now we create an inequality. We take the equation here, 4n minus 2, between closed minus 4 to 4. So we add 2 there, we add 2 there, we add 2 there, then we divide by 4. So get n between minus 0.5 and 1.5. So how many integers are there? The 0 and the 1 only. So there are 2 vertical asymptotes. Let's find them. N is equal to 0, put it in the equation here, so you get x equals minus 2. N is equal to 1, put it there in the equation, you get 4 minus 2, x will be 2. So you have the vertical asymptotes are minus 2 and 2 in the interval minus 4 to 4. Let's see the last part. Now, in the same interval, minus 4 to 4, we have graphed 1 period at the beginning. Now we can draw 3 periods here, just to see the interval minus 4 to 4. This is minus 4 to 4. We have drawn at the beginning from minus 2 to 2, 1 period. Now the graph is below the x. See the green part, below the x, from minus 4 to minus 2. That's below the x, you see? And now another green below the x, from 0 to 2 below the x. So we can say the graph is below the x from minus 4 to minus 2, union 0 to 2 on that given interval. Now, these are the answers of the 8 questions and their parts. You can, please, if you want to see more examples and the rules and how do we graph these functions, you can look at the lecture, please, 17, graphs of tan and secant functions. You can look and see the video on lecture 18. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much. Bye.